Hey everybody, and welcome back to Algebra 2 online. So this is going to be a pretty quick video. I really just want to do a few more problems kind of related to what we've studied recently. Nothing new here, just more examples. So to start off, I want to kind of think about this root equation with the idea of domain in mind. So if I take the domain of these things, okay, so let's do that one right here. So we would just have x minus 3 greater than or equal to 0, so x greater than or equal to 3. And then for this one, right, we'd have negative x plus 2 greater than or equal to 0. Just always take the inside, right, set greater than or equal to 0. Quick way to do this, just add x over, right? And so x is less than or equal to 2 on that one. And so if I graph this, okay, so let's do 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. X less than or equal to 2. And then, so this one actually is also shifted down 1, right? So, oh wait, and also I missed it almost, but there's a negative right there, right? So here's 2. So this one's only going to exist from here to the left, and then it's down 1 and it's flipped. So it flips and then shifts, I guess. So it'll also look like kind of like that, right? And then this other one, this yellow one here, there's a plus 2 on that one. So from 3, you go just like up 2 here, and then it's going to be some sort of, root function that's kind of the normal way we're used to it. So that's sort of what we have going on. And the question is, when is this thing equal to this thing? And you can see now that they're never equal, right? There's no solution to this thing. So sometimes if you use like the domain, you can actually kind of use that and maybe transformation of functions or something like that to solve the problem. So here, you don't even have to go in and try to solve this. And this would be pretty tough because there's a fourth root, and it would be like pretty annoying to deal with that. There'd be some like U sub tricks you could try and do, but this is a much more intuitive kind of quick way to do the problem. All right, so I just want to do another one of these basically rational exponent equation problems, okay? And I want to stress these 2 points. So whenever you look at these kind of things with the rational exponents, and I guess, even over here we have a rational exponent, but I'm talking about ones where you have like a non-trivial number on top and bottom, right? So like 4/3, different than like 1/3 or something. If it was 1/3, it's just a cube root, and that one would be pretty straightforward. Here, though, there's a little more going on because there's a 4. So kind of over here to my main point. So right when we look at that 4 right there tells me that there should be 4 answers, right? And that's just because it's like a polynomial of order 4, right? So I should get 4. That's something we saw in the last unit. And then this is another question I kind of go through in my head when I do these problems. Do I need to check my answers? And the reason is no, because we have a cube root going on, right? Anytime you really have an odd root at all, you don't even need to check. But you can check. It absolutely will still work, but you don't need to, right? So if I was doing this one, I'd probably, maybe I'll divide by 2 first. So I'm going to get 6x to the 4/3 minus 1 equals 5. And then let's add 5 over. Divide by 6. Okay. And then this is probably a good time to get rid of the cube root, right? So if you just take everything and cube it, then you would get x to the 4th equals 1. And, we know this is a nice polynomial. We've seen this one actually in a few problems. It's a difference of perfect squares. That one has nice plus minus I roots. And then this one has plus minus 1 roots, okay? And that'll be it. You don't have to check them. I mean, you can if you want, but they both work. All these definitely work. So that's just another example of like one of these kind of things you can get. So I really wanted to stress this part though. So when you see, if I have a problem where it's like somewhere in the problem is x to the 7/3 is the biggest one, you better get 7 answers, and you have an odd root again, so no need to check. That's kind of like a quick thing that I go through in my head right when I look at these problems. I just think about these two things, and I highly suggest you do too. A lot of times students won't get all the roots they need for the order of the polynomial. It's like they kind of forget about last unit. So don't forget about last unit.